Imagine boarding a brand new, state-of-the-art airplane, trusting it completely. Now imagine that same plane, minutes after takeoff, fighting against its own pilots, repeatedly forcing its nose down until it crashes. Sound like a horror movie? Nope, this was the terrifying reality for two Boeing 737 MAX flights. This isn't just about mechanical failure, it's a chilling story of how a single line of code, an unseen enemy, turned a cutting-edge jet into a death trap. What went so catastrophically wrong? Let's dive in. First, Lion Air Flight 610. October 2018. Just 13 minutes after takeoff from Jakarta, it plunged into the Java Sea. All 189 people on board perished. Then, barely 5 months later, Ethiopian Airlines Flight 302. March 2019. 157 lives lost, 6 minutes after takeoff from Addis Ababa. Two brand new planes, two virtually identical crashes. This wasn't a coincidence. This wasn't random bad luck. This was a pattern, a horrifying echo of a design flaw that would shake the entire aviation world to its core. The problem was systemic, and it was deadly. For decades, Boeing was synonymous with aviation excellence, a titan of the skies. The 737, specifically, is a workhorse, one of the most successful aircraft ever built. But even legends face pressure. When rival Airbus launched its fuel-efficient A320neo, Boeing scrambled to respond. They needed a new, competitive jet, and they needed it fast. Instead of designing a completely new aircraft from scratch, which takes forever and costs billions, they decided to upgrade their trusted, but aging, 737. What could go wrong with a little refresh, right? So, how do you make an old plane more fuel efficient? You slap on bigger, more powerful engines. Simple, right? Except the 737's original design, dating back to the 1960s, had extremely low ground clearance. These massive new engines, the LEAP 1B, couldn't fit under the wings without scraping the tarmac. Boeing's solution? Mount them further forward and slightly higher on the wing. Seems like a minor tweak, but in the hypersensitive world of aerodynamics, minor tweaks can have catastrophic consequences. This seemingly small change would ripple through the entire aircraft's behavior. Moving those huge engines forward and up had an unforeseen side effect. It changed the plane's center of lift. During certain maneuvers, especially when flying slowly with a high angle of attack, think taking off or climbing steeply, the MAX now had a tendency for its nose to pitch up even more aggressively than previous 737 models. This could potentially lead to a stall, a dangerous loss of lift that pilots are trained to avoid at all costs. Boeing needed a software fix to correct this new aerodynamic characteristic. Enter the Maneuvering Characteristics Augmentation System, or MCAS. MCAS sounds fancy, right? It was designed to automatically push the aircraft's nose down if it detected the plane was flying too slowly or at too high an angle of attack, mimicking the feel of older 737s. It was supposed to be a subtle, behind-the-scenes helper. The catch? Boeing decided this critical new system didn't warrant extensive pilot training or even a mention in the primary flight manuals. Pilots wouldn't know it was there, let alone how to fight it if it went rogue. A hidden feature, with lethal potential. Talk about a nasty surprise. Here's where it gets truly terrifying. MCAS relied on input from angle of attack, or AOA, sensors. These sensors tell the plane how much its nose is pointed up relative to the oncoming air. The 737 MAX had two AOA sensors, one on each side of the fuselage. But, and this is a huge but, MCAS was designed to take data from only one of them. A single faulty sensor, feeding bad data, could trigger the entire system. One sensor. One point of failure. It's like building a fortress but leaving one tiny, unduck that MCAS would be activated without any cross-check. Unbelievable. So, imagine this scenario, A single AOA sensor malfunctions, incorrectly telling MCAS that the plane's nose is too high and it's about to stall. What does MCAS do? Exactly what it was programmed for, it pushes the nose down. The pilots, confused and unaware of MCAS, pull the nose up to counteract. But the faulty sensor keeps feeding bad data, and MCAS, relentlessly, pushes the nose down again, over and over. It's an automated tug-of-war, with the pilots fighting against their own plane, against a system they didn't even know existed. Pure nightmare fuel. On that fateful day in October 2018, Lion Air Flight 610 experienced exactly this. A faulty AOA sensor. MCAS kicking in repeatedly, pushing the nose down. The pilots fought valiantly, trying everything they knew. They had control for moments, only for MCAS to re-engage, forcing the nose down again, and again, until it was too late. Imagine the terror, the confusion, as their state-of-the-art aircraft turned into a bucking bronco, determined to plunge them into the sea. This wasn't a manual error, it was a software-induced struggle against an invisible adversary. And no one was prepared. Despite the Lion Air crash, the full implications of MCAS weren't immediately understood or communicated. Pilots worldwide remained largely unaware. 5 months later, the nightmare repeated. Ethiopian Airlines Flight 302. Another faulty AOA sensor. Another instance of MCAS pushing the nose down repeatedly. The crew fought for control, using every procedure they could think of, but the system's relentless force was too great. The plane ultimately crashed, taking 157 lives. 2 identical crashes. 2 identical causes. The aviation world couldn't ignore it any longer. The Boeing 737 MAX was grounded globally. Modern aircraft are built with redundancy in mind. If one system fails, another takes over. It's Aviation 101. So, how did a single faulty AOA sensor bring down 2 planes? Because MCAS, the system designed to prevent stalls, itself became a single point of failure. There was no cross-check, no comparison between the 2 AOA sensors to verify data. Even worse, the pilots weren't adequately informed about MCAS, nor were they trained on specific procedures to counteract it. The backup was non-existent, and the awareness was missing. A catastrophic breakdown of safety principles. Think about it, seasoned pilots, with thousands of flight hours, were completely blindsided. The MCAS system was designed to operate subtly, in the background, making it incredibly difficult for pilots to even identify what was happening. When they pulled up, the plane pushed down. When they adjusted trim, it reset. It was a battle against an invisible force, coded into the very heart of the aircraft. Even if they suspected a runaway trim, the force of MCAS could be overwhelming. This wasn't just a software bug, it was a betrayal of pilot trust and training. Why did Boeing cut corners on such a critical system? The answer points to the ruthless pressure of the market. Boeing was desperate to get the 737 MAX to market quickly to compete with Airbus. Every extra bit of pilot training, every new manual update, every certification step costs time and money. By making MCAS invisible and claiming it behaved like existing 737s, they could avoid expensive, time-consuming retraining requirements. Market speed over rigorous safety testing. It's a stark ethical dilemma, where corporate profits were prioritized over fundamental safety principles. It's not just Boeing under the microscope. The Federal Aviation Administration, or FAA, is the watchdog, tasked with ensuring aircraft safety. But revelations after the crashes showed a system where much of the certification work for the 737 MAX was delegated back to Boeing itself. Boeing was essentially policing itself. This self-certification model, coupled with immense pressure to approve the plane quickly, allowed the MCAS flaw to slip through the cracks. Where was the independent scrutiny? The FAA's credibility took a massive hit, raising serious questions about regulatory capture. After the second crash, the world responded decisively. Country after country, airline after airline, grounded their 737 MAX fleets. This wasn't just an unprecedented move, it was a powerful statement of no confidence in Boeing's design and the FAA's oversight. Thousands of flights were cancelled, billions of dollars were lost, and Boeing's reputation, once pristine, was in tatters. The sight of hundreds of brand-new, expensive airplanes sitting idle on runways worldwide served as a stark, tangible reminder of the invisible software flaw that brought a global industry to its knees. To get the MAX back in the air, Boeing had to completely overhaul the MCAS system. The fix included several crucial changes. MCAS now takes input from both AOA sensors, comparing them to ensure consistency. If they disagree, MCAS is disabled. It also activates only once per event, not repeatedly, and its corrective power is significantly reduced. Plus, pilots now receive extensive training on MCAS, and it's clearly explained in flight manuals. These were the changes that should have been there from day one. A sobering lesson learned through immense tragedy. After nearly 2 years of being grounded, undergoing rigorous software updates, and pilot retraining, the Boeing 737 MAX slowly began to return to service. It was a long, arduous process to regain public trust. Airlines and regulators worldwide conducted independent reviews. While the physical aircraft remained largely the same, the critical changes to its software brain, and the increased transparency around its systems, were monumental. But the scars remain, a permanent reminder of the immense human cost when complex technology, regulatory oversight, and market pressures collide catastrophically. Ultimately, the Boeing 737 MAX story isn't just about a software flaw or engine placement. It's about people, the engineers who designed it, the executives who pushed for speed, the regulators who signed off, the pilots who fought valiantly, and the hundreds of innocent lives lost. It's a stark reminder that even with the most advanced technology, human decisions, ethical choices, and regulatory rigor are paramount. When any link in that chain breaks, the consequences can be truly devastating. Never forget that behind every piece of tech, there's a human responsibility. Fly safe out there.